Hi guys, Mr. Sonnenberg here. Today we're going to be talking about graphing velocity. So we will call this graph a distance versus time graph or a distance time graph. So what's going to happen is time, if I was going to draw myself just over here really quick, a graph which is extremely ugly, well, I'm going to plot time right here on my x-axis. And on what we call the y-axis or the vertical axis, I'm going to have distance. Okay, so then the line of best fit that joins data points gives us information. So, for example, if I was to draw a line like this, constantly increasing, then I would say that my velocity is increased. But if I was to draw a line that started up here and it went down, then I would say my velocity has decreased because over time the distance traveled was less. Okay, so we can tell a lot of data from these distance time graphs. So in a distance time graph, the title, which is written at the top, okay, is going to give us some information. So one, it's basically going to tell us what we're studying. Okay, oops, crap, what did I do? Sorry guys. Okay, it's going to tell us at the top, so I have my axes and then I write my title right here. Tell us what we're studying, and then it's also going to describe the variables, okay, or the changing aspects of the investigation. And so what we're trying to measure. So if I'm measuring the velocity of a baseball, okay, well, it's going to describe some time, okay, or from different distances. We all have that in the title, or make sure we have that in the title. That's going to help us out and tell us what we're going to be learning about. But the distance time graphs, there's two types of axes, and I showed you the one x-axis, which was the flat horizontal axis, and then there's the y-axis, which was the vertical axis. So the units of each variable, so the time is measured in seconds, and it goes on the x-axis, and then the distance measured in meters is on the y-axis, the vertical axis, okay? So then the x-axis shows the manipulated variable, and these next 2 points I really want you to know. The x-axis shows the manipulated variable, so that's the variable that is changed by the researcher, okay, and that's our time. And then the y-axis shows the responding variable, and that's the variable that's measured by the researcher as it changes as a result of changes to the manipulated variable. So if we change the time, then we're going to watch the distance respond to that, okay? So the slope is going to show us, well, whether the velocity was constant, which would be represented as a nice straight line, or if it was increasing, or if it was decreasing. And they'll be represented by straight lines for constant, or curved lines by changing. So I'll just show you in this graph right here. So we can see that, I'll just number them and I'll talk about them. So we can see that number 1 right here, okay, is increasing. We can see that number 2 is constant, and then number 3 is going to start decreasing, and we can tell by the changed lines, okay? So notice that this is the x-axis and this is the y-axis, and it tells us our distance, and this tells us our time, and time is measured in seconds and distance is going to be measured in meters, okay? And then we would have a title up here outlining what we're looking at, okay? So we understand different axes. Also know that this would be our manipulated variable. Oops, oh boy. And then this would be our responding at our y, okay? Right? Oops, okay. So when we're calculating velocity from these distance time graphs, we have to know there's two different aspects that we need to understand. So the run is the distance on the distance time graph shows the interval of time between 2 points. So interval of time means when did you start and when did you stop. So how long did it take between when you started and you stopped? So that's our interval. Okay, so because we know that we're talking about time, then we know that that's going to be our manipulated variable on our x-axis, which is our horizontal axis. Then the rise is on a distance time graph shows the distance interval between the same 2 points. So in that distance of time, so between say 1 second and 4 seconds, we started at 2 meters, we ended up at 6 meters, okay? So the interval is between 2 points. So we can calculate this velocity by using a formula called slope. So slope is going to, the formula is going to be v equals rise over run, or it's going to be distance, so v equals distance over time. So we've talked about velocity's formula, but now in a graph we'll call it rise over run, which is the same as distance over time. But remember, when we're solving these problems, we always have to outline the 5 steps. Okay, so what do we know? And I went through those in the velocity screencast, and you should have watched that before this one. So then you should have a handle on what I was talking about. Okay. All right, so slope, rise over run. So that's another way for us to determine if there's an increase or a decrease in velocity. So again, I'll just highlight that our manipulated variable goes on our x-axis, and our responding variable is on our y-axis. And our responding is our distance right here, and our manipulated is our time right here. Now, on this graph, our rise over run, if you take a look over at this image here, okay, the run is going to be on the x-axis, and then the rise is going to be on the y-axis. Okay, so for velocity, it's going to equal rise over run. Okay, so as I move my graph upwards like this, I could determine based on points on this graph, well, if that was 1 second, and that was 4 seconds, and that was 2 meters, and that was 6 meters, then I could say that this one was, okay, that this point here would be 2 and 1, and then this point here would be 6 and 4, and you just put a comma in brackets like that. Oh, that 6 doesn't look very good. Okay, so then we could calculate our rise versus our run. So it was the interval, right? So I could say v equals, what was my rise? Okay, well, if my rise was, and which is dealing with my distance, okay, well, it's distance over time, right? D over t, or v equals rise over run. I just love math. So, and it's the interval of time. Well, my rise was from 6, and then I have to go minus 2, because those are the points on the graph. And then we have 4 minus 1, so my velocity is going to equal 4 over 3. Okay, and then I would divide that and get a calculation, and that's going to determine my velocity. Okay, that's how those graphs work though. So I'll just show you a little practice problem here. Okay, so in this practice problem, you see the various points again. Okay, what do you know? Well, we know that the distance, or the interval distance, okay, is going to be, or we know the distance is going to be, and the points on the distance are, okay, which is going up and down on the vertical axis. Okay, so we started at 3 and we finished at 1. So we were at 3 minus 1. Okay, and we know that our time is going to equal, and we started at 0 and we finished at 4 minus 0. So what are we trying to find out? Velocity equals distance over time, or in our questions online, you might actually, it might look like this, d with a backslash and t. Okay, just because sometimes it doesn't work out on the computer. So I plugged that stuff in, so I'm going to get 2 over 4, and then it's going to determine my velocity here, okay, as well. And then, so remember, velocity is measured in meters per second, okay? So if you want to calculate that, then you actually have to divide it, and then you're going to get it a calculation in meters per second. So our distance, though, actually in this was, we started at 3 meters, and then we finished at 1 meter, so there was a 2 meter difference in the interval. And then in our seconds, we started at 0 and we ended at 4. So in this case, our velocity would be 0.5 meters per second. Okay, assuming that this was distance in meters and this was time in seconds. Okay, so that's how you can calculate. So if I simplified this, well, 2 over 4, well, I know that's 1/2. Well, half is 0.5, okay? So my velocity is 0.5 meters per second. All right, and hopefully you had the opportunity to try this out as well. Okay, but anyways, that's calculating velocity using distance time graphs, and hopefully this has helped. We'll see you on the next screencast. Bye.